Okay, so again, I'm going back to the discussion. So we'll be using the different identities for this type of process. So trigonometric functions. So pertaining to the different identities. So primarily on the Pythagorean identities. Okay. Now again, if you can see, so you have three different types. So you have sine and cosine, pair up, tangent and secant, and then lastly is your cotangent and cosecant. So if you try to recall your different Pythagorean equations, so the first one will pertain to sine squared theta plus cosine squared theta is equal to 1. The next is you have 1 plus tangent squared theta is equal to secant squared theta. And then lastly is you have cotangent squared theta plus 1 is equal to cosecant squared theta. So muna siya mga different formulas. Okay, so now if you try to recall on how to derive your Pythagorean identities, so let's say you're going to solve through the three types. So for you to be able to remember, because you will be utilizing these three formulas. So if you don't know how we derive those formulas, so going back to your trigonometry, so let's say we draw a right triangle. Okay, mauna siya ang Pythagorean Theorem, di ba? It's all about the right triangle. So we have A, B, and C as your hypotenuse. So for example, we're going to get the formula. So again, the sum of the squares of the two sides is equal to the square of the hypotenuse. That's the Pythagorean theorem. Now to get these formulas, kaning sine squared theta, kaning 1 plus tangent squared theta, and then the cotangent squared plus 1 and so on, is we let one specific angle be theta. So for example, this one is your angle theta. Okay. So next is by utilizing this formula of the Pythagorean theorem. So we first divide everything. So we divide everything by c squared. So what happens is we have a squared all over c squared plus b squared all over c squared is equal to 1, right? So furthermore, we can isolate the squared, or we can unify the terms into one squared term. So that will be a all over c squared plus b all over c squared is equal to 1. So how does the different trigonometric functions go into these equations? So looking at your drawing, so again, and basing on angle theta, so here is we have a all over c, and the other one is b all over c. So a over c is adjacent side all over the hypotenuse, so that's cosine squared theta, diba? Or if you don't want to put squared first, okay, so this will be cosine theta squared. Then the next term is b over c, so that's opposite the angle, then all over the hypotenuse. So that's the sine function. So sine squared theta is equal to 1. So finalizing the form, so we can put sine squared theta first. to exactly be para pareha siya sa atong equation. So cosine squared theta is equal to 1. So that's how you derive the Pythagorean identities. So since we divide by c squared first, so we can now divide by b squared. So for example, you're going to have a all over b squared plus 1 is equal to c all over b squared. So a over b in the drawing, that's adjacent side all over the opposite side. So that's cotangent function plus 1. And then c all over b, so hypotenuse all over the opposite side. So that's cosecant function. So cosecant squared theta. So finally is we divide by a squared. So we have So we have 1 plus b all over a squared is equal to c all over a squared. So again, from the triangle, b is the opposite side, a is the adjacent side, so that's the tangent function. And then c over a, so c is the hypotenuse all over the adjacent side, so that's secant function, so secant squared theta. So you now have the three different Pythagorean identities. So that's how you derive the equation. So for example, you forgot the exact designations for the Pythagorean formulas or Pythagorean identities, so you can derive your equations using a simple diagram of a right triangle. So again, why did I discuss this? Because we'll be utilizing these three formulas in your three types of transformations. Okay, so a little heads up. So for each type, so type A, type B, and type C, so each type will have two cases or two scenarios. Okay? Ang nag-record ako, so akong gamit kay OBS, akong gamit kay para, diba, if you have observed your uploaded videos sa Canvas, so murag smooth kay ang pag-drawing sa mga figures, diba, o sa mga equations. Yeah, if you try to compare it with Google Meet, so murag kuan siya lagi ba, diba? Murag dili kay siya smooth pagkasuwat. So muna akong gamit kay OBS kay para nindot siya og kanang quality ba. Okay. So we go first to type A. So for type A, case number 1. So again, type A case 1. So let's okay, so type A case number 1. So again, for type A is we have the integral of sine u to the power of m cosine u to the power of n with respect to u. So for case number 1, so it states here that either m or n is odd and positive integer. So meaning we have to observe your m or your n, and it should be odd and positive integer. Okay, odd and positive integer. So what do you mean by integer? So integer are counting numbers. Diba? 1, 2, 3, 4, 5, ano? Okay? Okay, if mahimo siyang fraction, so most likely your trig functions is under a radical expression. diba? So for example, you have u to the power of 1/2. So in radical terms, this is square root of u, diba? So that's why it's properly stated here that your exponent should be odd and it should be a positive integer. So meaning po siya whole number, di ba? Okay, so nakasiptan na tayo. So if you forgot the description of an integer, so you can search it up online later after this class. Okay, so again, we have to observe m or n is positive and odd. So for example, your m is odd. So we need to factor out sine u du. So sine u du. So factoring out sine u du. And then apply sine u squared is equal to 1 minus cosine squared u. So take note that this one comes from your first formula of your Pythagorean identities. Now if n is odd, which is the cosine function, so we need to factor out cosine u du. Okay? And then apply the corresponding Pythagorean identity of the cosine equation. So that's cosine u squared is equal to 1 minus sine u squared. So what do you mean by apply sine u squared and apply cosine u squared? So this means that, for example, mahabili na ang atong squared na kuan, so we need to replace it with this corresponding function. So cosine u squared will be replaced by 1 minus sine squared u. So muna siya. So kaning factored out na sine u du and factored out cosine u du, so this will be automatically your du function. So it's a probable candidate for your du function in the u sub technique. Okay. So we're still going to use u sub in our process. So this again, the factored out terms will be a probable candidate for du, because again, we cannot clearly state that it's the candidate already, because for example your angle has a coefficient, so it's not automatically that will be your u sub, because again in the derivative process it will still be multiplied by the coefficient of the angle, diba? So sige lang, ato na siya ma-appreciate later when we go to the example. Okay, so I think I have clearly discussed this one, so you can review this one later in the recording. Okay, so let's go to the examples. So let's go to the first example. So we have the integral of sine cube x times cosine to the negative 5x dx. So again, take note, if we try to put the summary of the case number 1 for type A. So again, m or n should be positive, so be odd, and then positive integer. Okay. So again, next, if m is odd, so factor out sine u du, diba? Now if n is odd, factor out cosine u du. So if m is odd, so apply sine squared u is equal to 1 minus cosine squared u. So if n is odd, so apply cosine squared u is equal to 1 minus sine squared u. Okay. Okay, and then after the whole process is we're going to use u sub technique. So that's the list of the steps. So again, determine first, and then next is we factor out. Then next is we apply the Pythagorean identity. And then lastly is your u sub technique. So we have 4 steps. So beginning with the solution. So again, m or n is odd. So looking at the exponents, so 3 and negative 5. So the other one is negative, so n is not a candidate for the case. So m is the correct one. Okay, so m. So kani siya, diba? So m is odd. So we need to use this m and then this one. So puro sine, diba? So factoring out sine u du. So of course, since we factored out sine u du, so this one becomes sine squared x, then cosine to the negative 5x. Then that's so this is the time that we write the factored out term on the right side. So in our common practice, so we usually put the factored out term on the left side. But in this case, we place it on the right side because again, this serves a purpose for the u sub technique later on. Okay, so again, this will be the candidate for your du term for the u sub later. So that's why bira nyo i-underline kaya para hindi siya ma-upilog distribute later. Okay? So next is we apply sine squared u is equal to 1 minus cosine squared u. So this term again will be replaced by this term. Ano siya? So, pati lang siya pagkasulti because the description states that you apply sine u squared, di ba? Not replace sine u squared with 1 minus cosine squared u. So, applying, or to be more specific, replacing or substituting. So you have 1 minus cosine squared x, okay, then multiplied by cosine to the negative 5x, and then again on the right side the factored out term sine x dx. Oops. So sine x dx. Okay, so again, if you don't want to be confused, so try to underline the factored out term para wa siya ilabot sa inyong process. So next is we distribute the terms. Distribute. So you have cosine to the negative 5x, then cosine squared, then cosine to the negative 5. So similar terms. So that's multiplication of exponents, di ba? Itong sa inyong exponential properties. So this will be cosine negative 3 x. So sine x dx. Okay. Okay, so next is we have to distribute, diba? So we can now use the u sub technique. So again, since we have done the first 3 problems, so it's time for us to use the u sub technique. So u sub, so let's try to use another color. So again, since this one is our du candidate, so again, if we try to reverse it, so the u should be cosine, diba? Because our du is sine x. So automatically our u should be cosine for us to get the sine x dx na du. Okay, so let u be equal to cosine x. And then the derivative of cosine is negative sine x dx. So that's what I meant earlier, that your sine x dx is just a candidate for du, because again, if we derived your du, so du is equivalent to negative sine x, which is not equal to the given term above, diba? So we still need to simplify things before we can declare that this one is really your du term. So negative du sine x dx. So instead of du, so this is negative du. So since we are done with the u sub technique, okay, so the rest is just integration. Okay, simplification process and finalizing your answer. So we have u to the power of negative 5 minus u to the power of negative 3, then negative du. So this is the time that we can now distribute your negative du so that we can simplify your integration process. So negative integral of u to the power of negative 5 du. That's your first term. So I automatically remove the negative sign outside the equation. So for the second term, that's minus u to the power of negative 3. So negative times negative is positive. So u to the power of negative 3 du. Okay. So next is we can now integrate using basic formula. So the first term is negative u to the power of negative 4 all over negative 4. Then plus u to the power of negative 2 all over negative 2 plus c. So negative, negative, that's positive. So u to the power of negative 4 all over 4 plus, so instead of plus, so that's plus times negative 1, so that's minus na. Okay, so u to the power of negative 2 all over 2 plus c. So again, don't forget to bring back the value of your u parameter. So that's cosine to the negative 4 x, then minus cosine to the negative 2 x all over 2 plus c. So this answer is correct. So if you don't want any negative exponent, so of course you can convert this one into its corresponding second term. Diba? So this will be second to the power of 4x all over 4 minus second squared x all over 2 plus c. So you can also have this answer because 1 over cosine is second. Okay, so either of the two can be your answer, or you can also have 1 all over 4 times cosine to the power of 4x, and as long as you don't want the negative exponent, so your answer is still correct as long as the final form is okay. So question, sige. Sige, ato nang i-solve later. Saan ang number gani? Sige, ato nang i-solve later after the discussion. Okay, number 16 no, sige, ato nang i-ano later. Okay, para makuan mo, ma-clarify mo sa kanang concern. Okay, so for this example, do you have questions? Okay, so wala ra. So let's proceed with the next example. So we have sine to the power of 4 2x, cosine to the power of 5 2x dx. So again, we need to observe the given exponents. So again, if you try to write the process, okay, so looking at your exponents, so the odd term is the cosine exponent. Okay, so n is the odd and positive. So since n is odd, so we need to factor out cosine u du. And then apply cosine squared u is equal to 1 minus sine squared u. And after is we use the u sub technique. So 1, 2, 3, and then 4. So 4 gyapon siya. Okay, so factoring out your cosine u du, so we have sine to the power of 4 2x, and then cosine to the power of 4 2x. So again, for us to be able to determine that we have factored out your cosine u du, so let's try to enclose this one with a parenthesis, and then write the factored out term on the right side. Okay. So next is we replace or we substitute your cosine u squared with 1 minus sine u squared. So looking at your cosine term, so since this one is to the power of 4, so of course we double the sub process, diba? So para mas madali ta, so sine to the power of 4 2x. Okay, so again, since this one is to the power of 4, so squared and squared is to the power of 4. So we have 1 minus sine squared 2x squared, diba? Okay, para to the power of 4 siya. Okay, and then the factored out term cosine 2x dx. Okay, so again on the right side is the factored out cosine u du. So di na ito nahilabtan. Okay, so expanding this term, since this one is the square of kanang difference in binomial, diba? So integral of, so sine to the power of 4 2x, and then multiplied, so bracket pa di gyapon eh. So 1 minus 2 sine squared 2x plus sine to the power of 4 2x, and then we have cosine 2x dx. Okay, so expanding. So multiply 3 times, di ba? So distribute. So the first term is just sine to the power of 4 to x. Second term is minus 2. So sine to the power of 6 na, di ba? 2x plus sine to the power of 8 2x, then cosine 2x dx. So if you try to arrange them by in descending order according to degree, so the first one will be your sine 8 to x, then next is your 6 to x, then lastly is your sine to the power of 4 to x, cosine 2x dx. So observing that your exponents are all even, so we can now use the u sub. So we are done with the first 3 steps. So next step is your u sub. So using the u sub technique, so again this one will be our candidate for du term. So automatically the derivative of sine is cosine. So our u parameter is your sine function, sine 2x. So again, the corresponding derivative is du is equal to 2 sine magyapon. So 2 cosine 2x dx. So again, isolating 2 so that we can exactly get cosine 2x dx. So this is du all over 2 is equal to cosine 2x dx. Okay? So replacing is we have u to the power of 8 minus 2u to the power of 6 plus u to the power of 4. Then this one is du all over 2. So expanding, so the first term is 1/2. So take 1/2 outside the expression. So that's u to the power of 8 du. So next term is we have 2 as the coefficient times 1/2. So it will neutralize in the second term. So minus u to the power of 6 du. And then lastly is you have 1 plus 1/2 u to the power of 4 du. So muna siya. So integrating is you have, for the first term is 1/2 times u to the power of 9 all over 9 minus u to the power of 7 all over 7 plus 1/2 times u to the power of 5 all over 5 plus c. So if you try to simplify and then replace u with your u function, so the first term is sine to the power of 9 to x all over 18 minus sine to the power of 7 to x all over 7 plus u sine to the power of 5 to x all over 10 plus c. So this is your final answer. Okay, so questions or clarifications? Okay, so I think there's no question. Okay, so let's proceed to the next case. So for case number 2, so earlier we observed that your m or n should be odd. So the opposite case for that one is that both, so take note, both m or n should be even and positive integer. Okay, so just ignore this one because ano siya labot. I forgot to delete this term. Then kanisad siya, nakuha na siya labot. Okay. So in case number 2, so both your exponents for the cosine and sine function should be even and positive. So if both are even and positive, so we need to apply these two terms. So we need to transform your sine u squared to this term, and transform this one to this term. Okay, so that all our values are in these terms na cosine degree 1. Okay, so this formula is a bit familiar. So in my previous class, so ingon siya nga this particular formula is the reduction formula daw, or reduction identity. So I don't know if ano ba na siya, but ang akong gibuhat man gud is I just use the half angle. So gikan ako sa half angle. So if you try to recall the half angle formula, so again I'm going to write it here, half angle. So that I memorize one formula only. So for sine half angle, so theta over 2 is equal to plus minus square root of 1 minus cosine theta all over 2. So getting the square is I have sine squared theta all over 2 is equal to 1 minus cosine theta all over 2, which is the same as this one, but the designation for the half angle is different. So we have u here, then we have theta over 2 here. Then on the transformation or the identity is you have 2u on the right side, but here in my formula it's just theta. But rest assured that the formula is the same gyapon. It will give you the same result as long as you declare your variables right. Okay, so again the same for the cosine function. So cosine half angle, so 1 plus cosine theta all over 2. Then getting the square, so cosine squared theta over 2 is equal to 1 plus cosine theta all over 2. So that's your formula for this one, the same. So again, it only differs in the angle declaration. Okay. So try to search lang this one, the reduction order. And I don't know what's the specific term, but mo to yung gingon sa akong student yesterday. Okay, so questions for the case number 2. So if you don't have any questions, so let's go on to the example. So you have the integral of sine squared 2x, cosine squared 2x dx. So again, if you write our process, so M and N, so M and M's, di ba, should be even and positive. So after obtaining this one is, of course, we need to replace this one with its corresponding value, di ba? So for sine squared, so let's try to use the formula stated in the previous slide. So 1 minus cosine 2u all over 2. Then for cosine squared u, that's 1 plus cosine 2u all over 2. Okay, so I think you only have 2 steps here, because after this one is you automatically integrate, because it's already simplified. Okay, cosine na ito ang function. Okay, so we have 3 steps. Okay, so again, your M and N are odd and positive. So what's next is we need to replace or substitute your sine u squared and cosine u squared identity. So before replacing, so of course we need to declare first your u angle. So u here, u on the right side, so sine squared, then u. Okay, so u here is 2x. Okay, so cosine squared, then u here is 2x. So it is the same gyapon, di ba? So pwede na ito siya dili isuot balik. Okay, so next is our 2u on the right side here, 2u. So to get 2u is we multiply it with 2. So that's 2u is equal to 4x. Now you might wonder if I'm going to use the half angle nga formula. Diba? So let's compare side by side. So again, if we write the half angle, so this will be theta all over 2. Diba? So let's say theta over 2 is 2x. Then multiply 2 to the other side. So theta is equal to 4x. So the same gyapon siya, diba? The same output. So muna, hindi na siya matter if whatever format you are using, basta as long as you properly declare your angles, so the resulting answer will be the same. Okay, so substituting your 2 terms, so the first term is 1 minus cosine 4x. So again, that's your 2u parameter all over 2. And 1 plus cosine 4x all over 2 dx. So if you try to multiply the 2 terms, so numerator against numerator, denominator against denominator. So looking at your numerator, that's the difference of 2 squares, diba? I mean the sum and difference of 2 squares. Sakto ba? Sakto ba ang term sa algebra? So shortcut, algebra, so 1 minus cosine squared 4x all over 2 dx. Okay, so take note that our cosine our numerator 1 minus cosine to the power 1 minus cosine squared 4x can be simplified into sine function, di ba? So sine squared 4x all over 2 dx. Now since squared man siya balik, di ba? It's still squared. So again, we still need to use this one again, di ba? So for you to be not confused, so let's try to factor out 1/2 first. Then we have sine squared 4x dx. Okay, so again, declaring our angles again. So u is 4x, 2u is 8x. Okay. I4 din A4. Sorry. A4 din A. Thank you. Um, 4 din siya. 4. 4 and then 4. Okay, so next is dapat niya siya 1/4 eh. 1/4. So 1/4. Then we have 1. So again, since it's sine, so 1 minus cosine 8x all over 2 dx. So factoring out 1/2. So 1/4 times 1/2, that's 1 over 8. Integral of 1 minus cosine 8 of x dx. So integrating the first term, so this will be x all over 8, then minus 1/8. Integral of cosine is positive sine, but since again we take note that we have a coefficient of the angle, so that's times 1/8 sine 8 of x plus c. So the final answer is x all over 8 minus 1 all over 64 sine 8x plus c. Or you can write it all in the numerator. Sine 8x all over 64 plus c. So this one is your final answer. Okay, so questions? Okay, going once, going twice. Okay. So I think okay ra siya. So let's proceed to the next example. So you have sine to the power of 4 2x. So again, if you write it on the upper right, our process. So ato lang yun siya i-write kaya para ma-remember ninyo. Okay, so m and n should be even and positive. So sine squared u is equal to, so if di mo ganahag u, so let's try using itong my formula from the previous meeting. So let's try using theta over 2. And then 1 minus cosine theta all over 2. Ah. Then cosine squared theta over 2. And we have 1 plus cosine theta over 2. Then lastly is we integrate. Okay? So steps 1, 2, then 3. So upon looking at the equation, so we only have 4 as the even function. So walay pairing cosine, di ba? So again, it states that m and n should be positive. But again, pinira walay n na even integer. As long as nalay isa nga even. Okay? So of course, ano pinira walay cosine because again, we are transforming your sine function, your square function into this particular term, a simplified version. Diba? So notice your cosine function is just the opposite operation of your sine function. So 1 minus cosine theta over 2, the other one is just plus. So it won't matter if walay cosine or sine in the given equation. Okay, so since this one is squared, to the power 4, so we need to multiply this one twice, diba? Or we square it. So we have, sorry. So sayop ko. So let's try to declare first paday your u parameter. Your theta parameter. So sine squared. So sine squared. Let's say you square this one. So instead of this one being 4, so this one is 2. Then squared siya, diba? The same declaration. So theta over 2 is 2x. So theta over 2 is 2x. Multiply 2 to the other side, so theta is equal to 4x. Okay? So next is we try to substitute your different kaning declaration na to late kanina. So we have 1 minus cosine. So theta is 4x all over 2 squared. Again, so if you don't want this term, so u is equal to 2x, 2u is 4x. The same gapon siya, di ba? Dx. So expanding. Okay, since it's squared man, so numerator is 1 minus 2 cosine 4x plus cosine squared 4x all over 4 dx. Okay? So taking 1/4 outside the equation, so what we have is 1 minus 2 cosine 4x plus cosine squared 4x dx. Okay, so upon observation, so the first term can be integrated, the second term can be integrated as well. But for the third term, since it's squared, so we still need to use again this term, di ba? This part of the process. So again, declaring again your u parameters. So u is equal to 4x. Dito u day. Basta ako naglibog sa. Sige, so theta all over 2 is 4x. Then theta is equal to 8x. So what happens is we have 1/4 integral of, so bracket first, 1 minus 2 cosine 4x, okay, and then plus 1 plus cosine 8x all over 2 dx. Okay, so removing the parentheses first is we have 1 minus 2 cosine 4x, so plus 1/2, diba? One term. Then the next term is plus cosine 8x over 2 dx. So this is the second term. Okay, so we can group together 1 and 1/2, diba? So you have 1/4 integral of 3/2. So ano na 3/2 na siya. So amo na ano. So cosine 2 cosine 4x plus cosine 8x all over 2 dx. Okay, so this is the time that we integrate. So integrating the first term, so that will be 1/4 times 3/2 of x, because the integral of 3/2 is 3/2 x. So minus 1/4 times 2, then the integral of cosine 4x, so take note that you have a 4 as the coefficient, so times 1/4 pa jud, and then sine 4x. Then lastly is your cosine term, the third term, so plus 1/4 times 1/2 coming from the over 2 of the cosine function. Then integral of cosine 8x, so take note again, you have a coefficient of 8, so times 1/8 cosine 8x, sine is sine. So sine 8x plus c. So finalizing your answer, that's 3x all over 8. That's for the first term. And then minus sine to the power of sine 4x all over, so 1/4 times 2 times 1/4, that will be 1/8, so over 8. And then plus, so 4 times 2, 8, so that's sine 8x all over 64 plus c. So this is your final answer. So you might wonder, ano, gubot kay siya. So I just try to compress the solutions in the screen. So I suggest that you try to solve your problems again na akong i-discuss. Mag side by side mo sa kaming recording later. Then if you don't understand that particular step that I was able to write in the recording, so try expanding it or making it more even simpler. So step by step jud ninyo ang inyong process para inyo makita ang kuan jud. Okay, so questions? Okay, so I think there's none. So now as we proceed with the second type. So type B, case number 1. Okay. So if n is even and positive integer, so n is pertaining to the second function. So we need to factor out second squared u du. Okay. And then use this particular identity, which is the second formula for the Pythagorean equations, Pythagorean identity. So second squared u is equal to 1 plus tangent squared u. Okay, so again, the factored out term is the candidate for your du parameter. So as you noticed, your second squared u du is your candidate for the derivative, diba? For the u sub. So of course, we can say that the u parameter will be tangent, diba? Because the corresponding derivative of tangent is second squared u du. So that's what you need to expect in this case. So for type B, case number 1. Okay. So trying example number 1. So again, if we try to write our steps, so n being the exponent of the second function should be even and positive. So next is we factor out second u du, diba? Excuse. Okay. And the next is we replace or we substitute your second u squared with 1 plus tangent squared u. Okay, then next is of course you integrate na. So 1, 2, and 3. So in the given equation, so we can see that n is already even, and it's in the second function, so we can apply. So notice that if we factor out, so check number 1. So next step is we factor out second u du. So notice that the numerator is already second u du. Diba? Yeah. In the third step, so if we try to replace your second squared u tangent u, diba? So murag kuan siya, diba? Murag mawala na ang second squared u du yung atong gi-factor out. Diba? Kani siya mawala ni siya kani. Yeah, which is our factored out term. So again, earlier in type A, case number 1, ang kato atong gi-factor out is di na to hilabdan, or you won't use the factored out term throughout the process. So after replacing the I, the fourth step is u sub. Diba? So since we cannot replace any term here, okay, mawala mo to atong gi-factor out, diba? So you can try to skip this process and then immediately go to u sub. So kung pasabutan na niya is dito na siya u sub, diba? So if we try to declare, so again, this factored out term is our candidate for du, diba? So let's say di siya u sub kay u naman day ang atong variable. So let's use z baron. So z is tangent u. Then dz is secant squared u du. Diba? So this one is our z parameter. The numerator is the dz. Okay, so muna siya itong mga kuan natin mga technique nga gigamit para dili kay ta maglisod. Okay, so simplifying it even further is we have dz in the numerator all over square root of z. So this one don't have a particular basic formula. So para mas mabasic siya is we move it to its exponential form. So negative 1/2 dz. So now we can integrate. So this will be z to the power of 1/2 all over 1/2 plus c. And then we have 2z to the power of 1/2 plus c. So bringing back the value of your z parameter, so the answer is 2 tangent u to the power of 1/2 plus c. Or you can bring back the radical expression 2 square root of tangent u plus c. Okay, so mao na siya. Okay, so any questions? Okay, so if you don't have questions, let's proceed with the next type. So for type P, case number 2, so this time is your m is the odd and positive integer. So m is odd and positive. So if the tangent exponent is odd, so we need to factor out sec u tan u. So again, the factored out term is our candidate for the du parameter in the u sub technique. So of course, if you imagine that the derivative is sec u tan u, so you think that the term is secant, diba? Because the derivative of secant is sec u tan u. Then after factoring out is we use our second formula for the Pythagorean identity. So tangent squared u is equal to secant squared u minus 1. Then after is you use u sub. Okay. So for you to be able to appreciate this case, type B case number 2. So let's try to solve another problem. Okay, so again m should be odd and positive. So after that one is we factor out sec u tan u du. Next is we substitute your Pythagorean identity. So tangent squared u is equal to secant squared u minus 1. And then lastly is we use the u sub technique or the sub technique. So 1, 2, 3, and 4. Okay. So notice that m, the exponent of the tangent function is already odd and positive, so we can proceed with type B, case number 2. So next is we need to factor out secant u tangent u du. So to do this, kung tanawin niyo ang ato ang secant is sa denominator. So if we try to get its corresponding exponential form, so we have tangent cube x, then this one will be secant x to the power of negative 1/3 dx. Okay, so if you try to factor out again your sec u tan u, so this one will be tangent squared because we got one tangent out of it. So how about the second term? If we remove negative 1, if we remove 1 from negative 1/3, so pila naman siya? Diba? So again, if di mo kabaw mo kuan, negative 1/3 minus 1 is, so ayan ka to, shortcut ang ingon. So looking at the denominator, diba? So negative 4/3. So negative 4/3 na siya. Then what comes next is your factored out term, secant x tangent x dx. So of course, if you try to expand it again, you try to multiply secant again back to the equation. So secant to the power of 1 plus negative 4/3. So the answer is negative 1/3 gyapon. So try to review this one later kay murag tricky kini siya nga kuan. Okay, so we have factored out your sec u tan u. So next is to replace sec u minus 1, sec u squared minus 1. So we have secant squared x minus 1, then secant x to the power of negative 4/3, secant x tangent x dx. So we need to expand, so multiplying. So 2 plus negative 4/3, so 2 minus 4/3, so 2, so again this will be 6 all over 3 for it to be 2, minus 4/3, so this will be 2/3 now. Okay, so for the first term is you have secant x to the power of 2/3, then minus secant x to the power of negative 4/3, secant x tangent x dx. Okay, so next is we're going to use u sub technique. Okay, so again, this one is our candidate for your du. So obviously our u is our secant parameter, then du is secant x tangent x dx. Okay, so u to the power of 2/3 minus u to the power of negative 4/3, and then du. Okay, So to have the first term is you have u 2/3 plus 1 is 5/3 all over 5/3 minus u to the power of negative 4/3 plus 1, that's negative 1/3 all over negative 1/3 plus c. So you have 3u to the power of 5/3 all over 5. So minus minus, that's plus 3u to the power of negative 1/3 plus c. So bringing back the value of your u parameter, that's 3 secant x to the power of 5/3 all over 5 plus 3 secant x to the power of negative 1/3 plus c. So this one is your final answer. Okay? So questions or clarifications? Okay, so if there's no question, so I think we'll discuss type C in the next meeting.